probably do this dozens, maybe even hundreds of times a day without even thinking about it. But have you ever stopped to wonder what really happens when you visit a website? I mean, you type in a web address, you hit enter, and bam, the page is just there. It totally feels like magic, right? But what's really going on behind that one little click is this incredibly complex, super high-speed dance involving computers literally all over the world. So, what's the secret? What actually happens in those few milliseconds between your click and the page loading? Well, we're about to pull back the curtain and break down one of the most amazing coordinated processes of our modern world. All right, so here's the game plan for this explainer. We're going to follow the entire journey of one single web request from start to finish. We'll kick things off with the absolute basics, the foundation. Then we'll see how your computer finds the right address using the internet's giant address book. After that, we'll watch it make a secure connection, have the actual conversation to ask for the web page, and finally, we'll take a quick look at how the web itself has changed over time. Okay, before we dive deep, we've got to clear something up. It's probably one of the most common mix-ups out there. The internet and the World Wide Web. They are not the same thing. So let's break that down. Think of the internet as the physical stuff, the hardware. It's the global network of all those undersea cables, the routers, the servers, all the physical wiring that connects everything together. Now, the World Wide Web, that's a service and application that runs on top of the internet. Kind of like how email or online gaming runs on the internet. The web is the system of websites and browsers that uses a protocol called HTTP to get you the information you're looking for. You know, Vint Cerf, who's basically one of the fathers of the internet, had the perfect analogy for this. He said the internet is like a massive global highway system. And the web? The web is just one type of vehicle that drives on those roads. It's the car we happen to use to visit all those websites. Okay, so you've typed in a web address. Sticking with that analogy, your browser's car is all gassed up and ready to go, but it has no idea where the destination is. It doesn't have a map. So the very first thing it has to do is look up the address in the internet's massive phone book. And that phone book has a name. It's called DNS, which stands for the Domain Name System. See, computers don't really get human-friendly names like example.com. They talk in numbers, specifically IP addresses. So DNS is that absolutely critical translator that takes the name you can easily remember and turns it into the numerical IP address that the computer actually needs to find its destination. Now, it's not quite as simple as just one giant phone book. It's more like a huge, organized library with a hierarchy. Your request first hits something called a recursive resolver. Just think of this as a super helpful librarian who's going to do all the running around for you. This librarian first goes to the root server. That's like the library's main index card, catalog. The index points them to the right section, the TLD server. TLD stands for top-level domain. So this is like the .com shelf or the .org shelf. And then finally, that shelf points to the authoritative server, which is the actual book on the shelf that has the exact IP address we've been looking for. So just to quickly recap that little chain of command, the librarian asks the main index, the index points to the right shelf, and the shelf points to the exact book containing the address. Each server in this chain has one simple job: pass the request down to the next level. And the crazy part, this whole lookup happens so incredibly fast, you don't even have time to blink. Okay, success. Our browser now has the IP address. It knows exactly where it's going. The next step is to actually open up a line of communication with the server at that address. And not just any line. It has to be reliable and private. This whole thing kicks off with something called the TCP three-way handshake. You can think of it like a very polite, very formal digital greeting to make sure both sides are ready to talk. First, your browser sends a little packet called a SYN, which basically says, "Hey, can we connect?" The server replies with a SYN ACK, which means, "Yes, I got your request and I'd also like to connect." Then your browser sends one last packet, an ACK, saying, "Great, connection established." And just like that, the line is open and reliable. So the line is open, but is it secure? Can anyone listen in? Well, if you look up at your browser's address bar and see that little padlock icon, that means there's one more crucial step happening behind the scenes to make sure the conversation stays private. And that's where the TLS handshake comes into play. You see, for any site that starts with HTTPS, and that S is super important, it stands for secure, a second handshake happens. This one is all about security. It checks the server's certificate to make sure it's legit, that it is who it says it is.
Then, your computer and the server agree on what encryption to use and generate brand new, unique secret keys just for this one session. From this point on, everything they say to each other is scrambled and completely private. So, now we have it all. A reliable, private channel is open. It's finally time for our browser to do what it came to do, actually ask for the web page. And to do that, it has to speak the official language of the web. That language is called HTTP, or Hypertext Transfer Protocol. Your browser sends out an HTTP request. It's pretty straightforward, basically saying something like, "Get me the main page." The server on the other end then sends back an HTTP response. This response includes a status code, and if all goes well, the actual payload, the HTML, CSS, and JavaScript files your browser needs to actually build the website on your screen. And that status code is really important. It's the server's way of telling your browser how things went. I'm sure you've seen a 404 not found before, right? That's a client error. It means you ask for something that just doesn't exist. If you get a code in the 200s, that means success. Everything is great. But a 500 level code, that means something went wrong on the server's side. As soon as your browser gets that sweet 200 OK and all the files, it can finally start the last bit of magic, turning all that code into the visual page you actually see and interact with. So that whole journey we just walked through, the DNS lookup, the TCP and TLS handshakes, the HTTP request, that core process has been remarkably consistent for decades. But the destinations themselves, the websites we visit, oh man, have they changed.
I mean, think about it. The early web, what we call Web 1.0, was basically a giant read-only encyclopedia. It was static. Then came Web 2.0, the read-write web. This is where things got interactive and social, where we all became creators on platforms like YouTube and Twitter. And now we're in the middle of this shift towards what people are calling Web 3.0, which is all about new ideas like decentralization and a more semantic AI-driven web. The key thing to remember is that even as the destinations get more complex, the fundamental journey to get there stays pretty much the same. All right, let's do a super quick lightning round recap of the whole trip. First, the DNS lookup finds the right address. Then, the TCP handshake opens a solid connection. After that, the TLS handshake locks it down and makes it private. And finally, the HTTP request asks for the page, and the HTTP response brings it home. It really is this beautiful, intricate dance between protocols and servers all over the world, and it all happens in less time than it takes to blink. This is the hidden architecture that powers every single click you make online. And, understanding these building blocks is more than just cool tech trivia. It's about seeing the real foundation of our digital lives. So now that you know how the highway system of the internet really works, what are you going to build on it?